This presentation will acquaint and assist maintenance personnel in preventative maintenance and rebuild of the Hendrickson E4 340 and E4 380 series four-spring suspensions. Proper service and repair is important for the safe and reliable operation of the Hendrickson tandem suspension. The service procedures recommended by Hendrickson and described in this presentation are effective methods of performing maintenance. Hendrickson offers the E4 series in 34,000 and 38,000 pound capacities. We recommend the E4 340 series for all over-the-highway vehicles where the tandem loads at the ground do not exceed 36,000 pounds. The E4 380 series should be used for over-the-highway operations where the tandem loads at the ground will exceed 36,000 pounds, but not over 38,000 pounds. Proper suspension selection should be based on the amount of carrying capacity required for a specific vehicle operation. Specifying the E4 380 for operations that do not exceed 36,000 pounds will not allow the suspension to perform as designed and may cause a reduction in ride quality. The E4 340 and the E4 380 suspensions are intended for installation on overall frame widths of 33.94 to 34.19 inches, axle dowel pin centers of 40 inches, and 52-inch axle spacing. They are lightweight, four-spring type suspensions designed to achieve maximum durability and low maintenance with no lubrication requirements. The design features include one-piece cast nodular iron spring hangers, 7/8-inch diameter U-bolts, and shot-peened and preset multi-leaf springs. The E4 340 uses .499 leaf thickness, and the E4 380 uses .558 leaf thickness. Shackled equalizing beam for better load distribution and articulation. Positive shackle restraint system in which a formed hook extension of the spring wrapper leaf extends through an opening in the shackle. This prevents the separation of the spring from the shackle should a main leaf failure occur. Cartridge-type rubber bushings in spring eyes. Cartridge-type rubber bushings in the equalizing beams. Longer center bushings with thrust washers minimize equalizing beam and shackle side movement during articulation and cornering. Premium rubber bushings in the torque rods. Standard torque rods use drop-in shims for adjustment. Optional torque rods have threaded turnbuckle type adjustment. Fifth wheel mounting angles that extend down over the side of the main frame rails must be cut out to provide clearance for the articulation of the equalizing beams and shackles, as shown here. Chassis frame slope in excess of 1 degree in the loaded condition will cause the equalizing beams to ride in a cocked position, that is, not parallel with the frame. This reduces the amount of available equalizing beam rotation in one direction. This condition should be corrected by adjusting the ride height at the rear tandem or at the front steer axle. If adjustment is required, the rear tandem usually must be raised to achieve a level frame since the E4 suspension is designed with a relatively low ride height. When increasing the rear tandem ride height, spacer plates of equal thickness must be installed between all four spring seats and springs. Do not attempt to compensate for cocked equalizers by adding spacer plates on only one drive axle. The spacer plates can be made from 1/2 inch by 3 inch by 7 inch long low carbon steel with a 13/16 diameter hole drilled in the center for spring center bolt head clearance. A maximum of 2 1/2 inch spacer plates between each spring and spring seat is permissible. Longer U-bolts will be required to accommodate spacer plates. Some vehicles with certain drive axle models will have axle angle adjustment wedges installed between the spring seat and the spring assembly for pinion angle settings. The tabs on the thick ends of the wedges identify the different wedge part numbers. If the vehicle is equipped with wedges for axle angle adjustment, the spacer plates must be located on top of the wedges. When installing spacer plates, position each plate on the center of the spring seat or wedge and tack weld the spacer to the rear edge of the spring seat casting or wedge using the stainless steel welding rod. Preventative maintenance. Proper preventative maintenance programs will help control repair costs and downtime. This is important for safe and reliable operation. For example, all new equipment should be given an initial pre-service inspection. This would include checking all tightening torques of the Hendrickson tandem suspension as specified by the truck manufacturer and as listed in the tightening torque specification chart in Hendrickson Technical Publication 17730-195. It is also recommended that tightening torques be checked with a torque wrench on a set preventative maintenance schedule. The frequency of this schedule should be determined by the equipment supervisor with knowledge and experience of the type of operation and mileages involved. Alignment of the suspension should be performed after all repairs are completed and all suspension fasteners have been tightened to specified torque values. Place the tractor on a level floor area. Free and center all suspension joints by slowly moving the vehicle back and forth several times without using the brakes. The equalizing beams should be essentially level in this condition. Chock the front wheels and make sure the tractor brakes are released. Using C-clamps, securely clamp a 9-foot piece of straight bar stock or angle iron across the frame. Select a location as far forward of the forward drive axle as possible where vehicle components will not interfere. On some vehicles, the lower frame flange may be preferred. Otherwise, use the upper frame flange. Accurately square the straight edge to the frame using a carpenter's square. Begin alignment by checking the rear drive axle first. Use a trammel bar, or its equivalent, to measure from the straight edge to the center line of the rear drive axle on both sides of the vehicle. If both sides measure within 3/16 inch of being the same, the alignment of rear drive axle is acceptable. If the measurements differ by more than 3/16 inch, adjust the rear drive axle by loosening up the torque rod bar pin lock nuts on the center spring hanger and add drop-in shims. The torque rod bar pin must always be mounted adjacent to the forward face of spring hanger legs. No more than 4 shims may be used equaling 1/4 inch total thickness. Snug the torque rod bar pin lock nuts, but do not torque to specification yet. If the vehicle is equipped with threaded turnbuckle type torque rods, loosen all the torque rod clamp bolt lock nuts and rotate the threaded shank of the torque rod. Snug the clamp bolts, but do not torque to specification yet. With the rear drive axle properly aligned, the front drive axle alignment can then be checked by measuring forward from the rear drive axle center using a trammel bar. If the forward drive axle spacing measurements differ by more than 1/8 inch, make adjustments at the forward spring hangers in a similar manner. Snug the torque rod bar pin lock nuts or turnbuckle clamp bolt lock nuts. Following the alignment of both axles, move the vehicle back and forth several times prior to removing the straight edge from the frame and recheck the alignment to confirm your adjustments. Then tighten the torque rod bar pin lock nuts to 95 to 130 foot-pounds torque. Or the turnbuckle clamp bolt lock nuts to 70 to 95 foot-pounds torque and remove the straight edge. Hendrickson recommends the U-bolt lock nuts be retightened to 230 to 310 foot-pounds torque after the first 1,000 miles of service on a new vehicle or a vehicle with a serviced spring assembly, and then at each 100,000 miles thereafter. We also recommend that springs be inspected for cracked or broken leaves. A single leaf may be replaced if the spring has been in service for less than 200,000 miles. The entire spring assembly should be replaced if more than one leaf has failed, regardless of the mileage, or if only one leaf has failed and the spring has been in service for over 200,000 miles. The tires and rims have been removed from one side of this vehicle to better show the following service procedures. Normally, most servicing can be accomplished without removing them. The following procedure is recommended to replace any of the 4 spring assemblies. All 4 springs are identical. Chock the wheels of the axle and remove the rebound bolt, lock nut, washers, and the spacer from the end spring hanger. Raise the rear of the frame far enough to remove the load from the springs. Straighten the keeper tabs on the bolt retainer plate. And loosen both the upper and lower shackle bolts. Remove the U-bolt lock nuts, washers, and bottom cap. Remove the U-bolts and top pad. Remove both shackle bolts. The frame may have to be raised for the bolts to clear the tires. Discard the shackle bolt retainer plate because the keeper tabs can only be bent once. Remove the spring assembly. The spring can then be repaired or replaced. Normally, the spring eye bushing should be replaced at this time if the same spring is going to be reinstalled. The bushings used in the spring eyes are the same as those used in the ends of the equalizing beams. Also, the same push-out and installation tools are used. Shop-made tools, as shown in Hendrickson Technical Publication 17730-195, can be used for spring eye bushing removal and installation, and for equalizing beam bushing removal and installation. The Owatonna Tool Company also has tooling for these operations. Use a vertical shop press with a capacity of at least 15 tons. Be sure the spring is squarely supported at the eye on the press bed for safety. Press out the old bushing, making sure the pushing tool contacts the outer metal of the spring eye bushing. Do not use heat or a cutting torch to remove the bushing outer metal that is pressed in the spring eye. The use of heat will adversely affect the strength of the spring eye. Clean the spring eye with emery cloth to remove any nicks or metal buildup from bushing removal. Clean the outer metal of the new bushing with emery cloth to remove the phosphate coating, which acts as a rust preventative. Apply a thin coat of rust preventative on the outer metal of the new bushing. Press in the new bushing, making sure the pushing tool contacts the outer metal of the bushing. Center the bushing in the spring eye. Remove any remaining rust preventative from the ends of the rubber bushing. The end faces of the bushing should be clean and dry before assembling the spring into the shackles. To install the spring, position the shackle on the eye of the spring assembly. The hook must pass through the opening provided in the shackle. The threaded bosses of the shackle must be positioned toward the truck frame. Assemble one shackle bolt with a new shackle bolt retainer plate through the upper shackle hole and spring eye. Position the spring with shackle attached on the spring seat with the center bolt head piloting into the countersunk hole. Or on the spacer plate if so equipped, with the spring center bolt head piloting into the spacer plate hole. While aligning the lower shackle legs over the equalizing beam end bushing. Assemble the lower shackle bolt through the retainer plate, shackle hole, and equalizing beam end bushing. Hand tighten the shackle bolt. Assemble the top pad, U-bolts, bottom cap, washers, and lock nuts. The taller ribs of the bottom cap must be positioned toward the rear of the vehicle. Do not tighten the U-bolt lock nuts at this time. Lower the frame so that the end spring hanger engages the spring. Then tighten the U-bolt lock nuts to 230 to 310 foot-pounds torque. Wrap the top of the U-bolts and retighten the nuts to 230 to 310 foot-pounds torque. Tighten both shackle bolts to 230 to 310 foot-pounds torque. And bend all retainer plate keeper tabs against the bolt heads. Assemble the rebound bolt, spacer, washers, and lock nut in the end spring hanger. Tighten the lock nut to 49 to 66 foot-pounds torque. Recheck the suspension alignment after a new spring is installed. The following procedure is recommended to replace the equalizing beam rubber bushings. Chock the wheels of the rear drive axles and support the rear of the frame. Remove the torque rod bar pin lock nuts, bolts, washers, and any alignment shims from the center spring hanger. Note the number of shims at each location. These shims must be reinstalled in the same manner to avoid affecting alignment. Straighten all the keeper tabs on the shackle bolt retainer plates and remove all the shackle bolts. Discard the shackle bolt retainer plates because the keeper tabs can only be bent once. Reinstall the upper shackle bolts through the spring eyes with new shackle bolt retainer plates, but do not tighten at this time. Remove the center spring hanger to equalizing beam lock nut and washer, and push out the bolt. Lower the frame so that the equalizing beam ends drop clear of the shackles, and slide the equalizing beam forward and down out of the center spring hanger. Note that there are thrust washers between the center bushing and the spring hanger legs, one at each end of the center bushing. Use a vertical shop press with a capacity of at least 15 tons to press out the old bushings. Do not use heat or a cutting torch to remove the bushing outer metals that are pressed in the beam. The use of heat will adversely affect the strength of the beam. When removing beam bushings, be sure the beam is squarely supported at the bore area on the press bed for safety and to avoid bending the equalizing beam. Be sure the pressing tool evenly contacts the outer metal of the center bushing and press out the old bushing. Press out the old end bushings in the same manner. After pressing out the old bushings, clean the bores of the equalizing beam with emery cloth to remove any nicks or metal buildup from bushing removal. Clean the outer metals of the new bushings with emery cloth to remove the phosphate coating, which acts as a rust preventative. Apply a thin coat of rust preventative on the outer metals of the new bushings. Press in the new center bushing. The pushing tool must contact only the outer metals of the bushings. Press in the new end bushings. All bushings must be centered in the beam bores. Remove any remaining rust preventative from the ends of all the rubber bushings in the beam. The end faces of rubber bushings should be clean and dry before assembling the beam into the shackles and the center spring hanger. Position the equalizing beam with thrust washers in the center spring hanger. The ID of the thrust washers must fit over the OD of the center bushing intermetal. There must be one thrust washer at each end of the center bushing. Assemble the equalizing beam to center spring hanger bolt, washers, and lock nut. With the equalizing beam parallel with the frame as viewed from the side of the vehicle, tighten the lock nut to 365 to 495 foot-pounds torque. Raise the frame until the equalizing beam end bushings line up with the lower shackle bolt holes and assemble the lower shackle bolts. Tighten both the upper and lower shackle bolts to 230 to 310 foot-pounds torque. Bend all the keeper tabs against the shackle bolt heads. Position the straddle mount bar pin end of the torque rod at the forward face of spring hanger legs and reassemble the bolts, washers, lock nuts, and any alignment shims as noted during disassembly. Tighten the lock nuts to 95 to 130 foot-pounds torque. The following procedure is recommended to replace the torque rod bushings. Chock the wheels of the drive axles and remove the lock nut, through bolt, and washers at the axle end of the torque rod. If a forward torque rod is to be rebushed, loosen the rebound bolt lock nut in the forward spring hanger. Remove the straddle mount bar pin lock nuts, bolts, and washers, and any alignment shims at the spring hanger ends of the torque rod. Note the number of shims as they must be reinstalled in the same manner to avoid affecting alignment. Use a vertical shop press with a capacity of at least 10 tons to push out the old bushings. A 5-inch long piece of 2-inch ID by 1/4 inch wall steel tubing receiving tool is required. These bushings are not cartridge-type bushings. They do not have outer metals. Support the torque rod end on the receiving tool with the end tube of the torque rod centered on the tool. Push directly on the bushing inner metal or straddle mount bar pin until the bushing clears the torque rod end tube. Clean and inspect the ID of the torque rod ends, removing any nicks with emery cloth. Lubricate the ID of the torque rod ends and new rubber bushings with a vegetable base oil such as cooking oil or lard. Do not use a petroleum or soap-based lubricant. To press in the new bushings, support the torque rod end on the receiving tool. The straddle mount bar pin type bushing must have the mounting flats positioned perpendicular to the shank of the torque rod. Press directly on the inner metal of the bushing. When pressing in new bushings, overshoot the desired final position by approximately 3/16 inch and press the bushing again from the opposite side to center the bushing within torque rod end. To install the torque rod on the vehicle, position the through bolt end of the torque rod in the spring seat and assemble the through bolt, washers, and lock nut. The through bolt head must be installed toward the center of the vehicle. Hand tighten the lock nut. Position the straddle mount bar pin end of the torque rod on the forward face of the spring hanger legs and assemble the bolts, washers, lock nuts, and any alignment shims. Tighten the lock nuts to 95 to 130 foot-pounds torque. The center spring hanger to equalizing beam attaching bolt lock nut must be tightened before the torque rod is installed. Tighten the through bolt at the axle end of the torque rod to 360 to 460 foot-pounds torque. After installing a straddle mount bar pin end to a forward spring hanger, tighten the rebound bolt lock nut to 49 to 66 foot-pounds torque. If the spring hangers require replacement, attachment to the frame should follow the vehicle manufacturer's specifications for the fastener tightening torque values. Hendrickson recommends the use of grade 8 bolts, grade C lock nuts, and flat-plated hardened washers under the bolt heads and lock nuts. Proper service and repair is important for the safe and reliable operation of the Hendrickson tandem suspension. Before service is performed, it is important that the service instructions and safety warnings as covered in technical publication 17730-195 be understood. These warnings cover harmful effects of using a cutting torch and other safety-related items. Do not modify or rework parts. Use only genuine Hendrickson parts for servicing the suspension. Most parts can be identified by the Hendrickson H symbol.